Welcome to all my dear students. Today we are going to discuss about the topic binomial theorem. An algebraic expression consisting of two terms connected by plus or minus sign is called a binomial expression, or simply we say binomial. For example, x plus 2y, L minus m, p plus 2q, m plus n, etc. All binomial expressions are binomial. The prefix bi in the word bicycle, binocular and binary, and in many words means by two. The word binomial stands for expression having two terms. In earlier chapter 4, we discussed a simple NCR, which is defined n factorial divided by r factorial into n minus r. The expansion 1 plus x whole power n belongs to n, nc0, nc1, nc2, etc. ncn are called a binomial coefficient. These coefficients are briefly written as C0, C1, C2, etc. Cn. By actual multiplication, we can obtain the expansion of a plus b whole power 0. If I am asking you a plus b whole power 0, you know anything power 0, you are getting 1, so you say the value a plus b whole power 0, 1. If I am asking a plus b whole power 1, definitely you all know a plus b whole power 1, we get a plus b. If I am asking a plus b whole square, some of you will say, sir, it is a formula, already we know that a plus b whole square equal to a square plus 2ab plus b square. Someone think, sir, we write a plus b whole square, a plus b into a plus b, multiply, we get the expansion of a plus b whole square. Suppose if I am asking a plus b whole cube, similarly you people, you know a plus b whole cube formula, I was saying a plus b whole cube, I am saying very good. Some students thinking about a plus b whole cube, sir, a plus b whole cube, we write a plus b into a plus b into a plus b, multiply, we get the a plus b whole power 3 expansion values are very good. It is not difficult to find a binomial expansion of power 2 or 3, but in the process for finding the expansion of binomial with higher power, such as a plus b whole power 17 or a plus b whole power 25 or a plus b whole power 75, it becomes more difficult for finding the power of higher in a binomial. Therefore, we look for general formula which helps expansion of binomial with higher order. The binomial theorem helps us to expand any power of given binomial. The binomial theorem first established by Sir Isaac Newton, first formulated by Sir Isaac Newton, mathematician. Next, Pascal triangle. Pascal triangle is an arrangement of terms of NCR, is in a triangular form. 1, 1, 1, we write 1, 1. Every row start with 1 and also end with 1. 1, 1. It seems to be like a tree or triangle. 1, 1. The remaining numbers are to be obtained by only adding. We want to this row remaining number, you can add previous row, left number and right number, we get 2. 1 plus 1, we get 2. We want the number of this row, we can add 1 plus 2, we get 3. 2 plus 1, we get 3. Similarly, we can fill the Pascal triangle. 1 plus 3, we get 4. 3 plus 3, we get 6. 3 plus 1, we get 4. You say this row, 1 plus 4 what? 5. Good. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Similarly, we can get every row. You should know how we get the Pascal triangle. 1 we write 0 C 0, this row 1 1 we write 1C0, 1C1. Using NCR formula, n factorial divided by r factorial n minus r factorial, we get 1C0 1C1 also 1. Here the binomial coefficient we write 2C0, 2C2 and 2C1. Similarly, we can write for the coefficient 1, 3, 3, 1, we write 3C0, 3C1, 3C2 and 3C3. You find the value of 3C0, we get 1, 3C1 using formula, NCR formula, we get 3, 3C2 we get 3 and 3C3 we are getting the value 1. This is the way the coefficient, the triangle coefficient we are getting by using the NCR formula. From the Pascal triangle we can get the binomial identity. Here 1 we write a plus b whole power 0, we are getting 1. This we write 1 1 a plus b whole power 1, we get a plus b. This we write the coefficient we use 1 to 1, giving a plus b whole square identity. First we take it 1, then 2, 1. 1 to 1 are binomial coefficient. First we take it a square, then a square we decrease power 1, so we get a. End we have b square, we start with the b square, decreased by 1 power, from right to left we get b. So a plus b whole square getting a square 2ab b square. Here the coefficient 1 3 3 1 giving a plus b whole cube formula. So we trying to find a plus b whole cube expansion, we take it a coefficient 1 3 3 1. First I start with the a cube, then gradually the power of a is decreased by 1. Okay, a cube, a square, a. Then ending the right side, we take it b cube. Similarly, gradually the p cube reduced by 1. We get b square, b. So the expansion a plus b whole cube we get. I am asking you, you people, you are going to find out the formula for a plus b whole power 4. What you have to do? First you take it the coefficients 1 4 6 4 1. We are finding a plus b whole power 4. Next you start with a power 4, then a cube, a square, a. Then end we start with the b power 4, b cube, b square, b. Take it plus symbol. This is the expansion of a plus b whole power 4. Similarly, we are going to find out the expansion of a plus b whole power 5. We know the idea. First we take it here coefficients 1, 5, 10, 10, 5, 1. Here you see a power 5 is there. So we take it a power 5 first, then a power 4, a cube, a square, a. End with the b power 5. So we end with the b power 5 starting b power 5, b power 4, b cube, b square plus b. This is the expansion of a plus b whole power 5. You see the power of a is gradually decreased by 1, a power 5, a power 4, a cube, a square, a. And the power of b gradually increasing by 1, b power b square, b cube, b power 4, b power 5, starting with the b power 0. The power b gradually increasing by 1. But the power of a and b, we get 5, 3, 2, 4, 1, 2, 3, 1, 4. The power of a and b is 5. You know all the Pascal triangle can be constructed by using addition only, not using multiplication, not using division. So we find a plus b whole power n expansion, n belongs to n without using multiplication. The pattern resembling a triangle, Pascal triangle is created in the name of the 17th century French mathematician Pascal, who studied mathematical properties of the structure and used this concept effectively in probability theory. Binomial theorem for positive integral index. Theorem 5.1. If n is any positive integer, then a plus b whole power n equal to nc0 a power n b power 0 plus nc1 a power n minus 1 into b power 1 plus nc2 a power n minus 2 into b square plus etc. plus ncr a power n minus r b power r plus dot 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 plus ncn a power 0 b power n. Binomial expansion. We say it is a binomial expansion. We shall prove the binomial theorem by using mathematical induction. So, let P of n be the statement. P of n a plus b whole power n nc0 a power n b power 0 nc1 a power n minus 1 b power 1 nc2 a power n minus 2 b square plus dot 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 ncr a power n minus r b power r plus dot 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 ncn a power 0 b power n. Just we take it given a plus b whole power n as a p power n. Step 1. First put n equal to 1. LHS of statement p of 1, RHS of statement p of 1, we check a plus b. The LHS we put n equal to 1. Here on right side we put n equal to 1, 1 C0 a power 1 b power 0. Here 1 C1 a power 1 minus 1, that is we get 0 b power 1. The left side a plus b whole power 1, we get a plus b. Right side 1 C0 1 C1, the values we get 1. So, 1 into a power 1 a into b power 0 value 1. So, a into 1 we get a. Here 1 into 1 a power 0 1, we get only plus b. LHS and RHS of p of 1 is equal. So, we say p of 1 is true. Similarly, we put n equal to 2 and n equal to 3, the theorem is true. So, step 2, let us assume that p of k be true. For n equal to k, the theorem is true, we should prove. So, assume that p of k, let p of k be true. So, p of k a plus b whole power k equal to k c0 a power k b power 0 k c1, we put n for k, k c1 a power k minus 1 b power 1 k c2 a power k minus 2 b square plus etc. dot 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 k cr a power k minus r b power r plus dot 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 plus k c k a power 0 b power k is be true. We assume that p of k be true. Step 3, we have to prove p of k plus 1 is true. So, to prove p of k plus 1 is true. So, we find a plus b whole power k plus 1. You know that a plus b whole power k plus 1, we write a plus b into a plus b whole power k. The power you can add, we get a plus b whole power k plus 1. So, a plus b, you know the value of a plus b whole power k, you take it k c0 a power k b power 0 k c1 a power k minus 1 b power 1 k c2 a power k minus 2 b square plus etc. k c r a power k minus r b power r plus dot 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 k c k a power 0 b power k. Just we take it a plus b into a plus b whole power k value from the above step. Okay, next we multiply with the a to every term of the bracket. So multiply with the a each term of the bracket. So a k c 0 a power k plus 1, a into a power k plus 1, b power 0. Multiply with the a k c 1 a power k, b power 1. Multiply with the a k c 2 a power k minus 1 b square. A into kcr into a power k minus r b power r. We get kcr a power k minus r plus 1 b power r plus dot 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 kck a power 0 into a, we get a power 1 b power k. We multiply b with every term of the inside the bracket. Okay, then b into kc0 a power k b power 1, then kc1 a power k minus 1 b square, then kc2 a power k minus 2 b into b square, we get b cube dot 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 kcr a power k minus r b into b power r, we get b power r plus 1 plus dot 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 plus you get here b into kck a power 0 b power k, we get kck a power 0 b power k plus 1. We have done multiplication with a plus b into a plus b whole power k, we get this. Then we can add, take it as it is, first term kc0 a power k plus 1 b power 0, take it as it is, and also last term as it is we take it. Then we add a power k b power 1 coefficient. So we add kc1 plus kc0 a power k b power 1. Similarly, you know the idea, then take it a power k minus 1 b square coefficient, we add, we get kc2 plus kc1 into a power k minus 1 b square. One question I am asking to you, you should say what is the term before kcr a power k minus r b power r minus 1. Here we get kc, here you see kc0, kc1, kc0, kc2, kc1. So I need here kcr, before that we need kcr minus 1 plus etc. kcr minus 1 a power k minus r plus 1 b power r, b power r. So we can add kcr plus kcr minus 1 into a power k minus r plus 1 b power r. Finally we have last term, we take it kck a power 0 b power k plus 1. Here we are going to use one identity. We know that kcr plus kcr minus 1 k plus 1 c r. Put r equal to 1, we get here kc1 plus kc0 1 minus 1 0 equal to k plus 1 c r equal to 1. We get kc1 plus kc0. Here the value we get, we are going to apply kc1 plus kc0. Here going to apply k plus 1 c1. Then when r equal to 2, we get here k c r equal to 2. So put 2 for r, k c 2 minus 1 1. Here we put r equal to 2, we get k plus 1 c2. So the value we get kc2 plus kc1. Here we are going to apply the value kc2 plus kc1, k plus 1 c2. Here directly we use the identity KCR plus KCR minus 1, we take it here K plus 1 CR, and also we know that KC0 equal to 1, so K plus 1 C0 also 1, not only KC0 1, K plus 1 C0 equal to 1. So here KCK we know the value 1, so that we get K plus 1 C K plus 1 value also 1. So the results, these results we are going to use here. We get A plus B whole power K plus 1 equal to KC0. KC0 we write what? K plus 1. KC0 we take it K plus 1 C0. C0 A power K plus 1 B power 0. The value of K plus 1 plus KC0, already we have K plus 1 C1. K plus 1 C1 into A power K B power 1. The value of KC2 plus KC1, you know that KC1 plus K plus 1 C2 into A power K minus 1 B square plus dot dot dot. Here KCR plus KCR minus 1, we use the identity K plus 1 CR into A power K minus R plus 1 B power R plus KCK. You know that KCK value 1, K plus 1 C K plus 1 value also 1. For our convenient, we are taking KCK for K plus 1 C K plus 1 A power 0 B power K plus 1. Next we write A plus B whole power K plus 1, K plus 1 C0 A power K plus 1 B power 0. Here K plus 1 C1 A power K, we write K plus 1 minus 1, adding 1 subtracting 1. For convenient we write here K plus 1 C2 A power, adding 1 and subtracting 1. Here we get K plus 1 minus A power K plus 1 minus 1. Here A power K plus 2 minus 1. We are getting K minus 1. A power K minus 1, we bring A power K plus 2 minus 1. How we get means adding 1 subtracting 1. So B square. Similarly we get K plus 1 CR. This we write K plus 1 minus R B power R. Finally K plus 1 C K plus 1 A power 0 B power K plus 1. This shows P of K plus 1 is true whenever P of K is true. Thus the principle of mathematical induction, P of n is true for all n belongs to n. Hence binomial theorem for positive integral index A plus B whole power n is proved.